Welcome this evening to the Future of Graph panel here at Day Texas and the Global Graph Summit. My name is Josh Perryman. I'll be moderating the panel today, and they are terrified of the questions that I have here. Now, panels, in large part, are very academic and boring, and 3 of the people up here have PhDs. So this is not going to be anything like that, because what I have decided is that what a graph panel discussion really needs is a strong injection of whose line is it anyways. I have decided that I have here 5 different fouls which I may call throughout the session here. We'll be looking for marketing Muppets. So if you are parroting whatever your vendor thing is, and if you guys can go ahead and anytime I call a marketing Muppet, just go do 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 do. That would be really cool. We're also aware that there's going to be a potential for shameless self-promotion. And so I might call them on that. Now, it is entirely possible that someone could subtly self-promote or maybe realize that they were shamefully self-promoting and then enact something like shame, in which case the points may go from negative to positive. So there is some way to game the system with this. No, there is no points being tabulated. They might be tabulated. No, Dave's not writing anything down. He's already his 4th beer, so we're not going to get anything good out of him. Not my nomenclature, not expecting to see too much of that, but if you see someone that's from one part of the graph ecosystem using terms from another part of the ecosystem, then we might call not my nomenclature on that. That would be bonus points for that, for spreading the love. Academic obfuscation, right? Where we use overly academic terms to describe really simple things like fast disk access or something like that. And then, if necessary, I might call an RDDB BS. In addition, I have listed here 1, 2, 3, 4, 5, 6, 7 obscure terms. And so there are 50 bonus points available should any of the panel members accidentally say one of the obscure terms. So we will call an OT obscure term, explain what that is, and then maybe they might explain why they chose to use such an obscure term in a panel discussion like this. I've been talking for too long already. This is definitely a shameless self-promotion example. We'll start with Josh on the far, I guess, left from your perspective, right from mine. And I'm going to ask them to introduce themselves and tell a little bit about just what their name, title, and kind of current area of focus or attention is. Josh?
All right, name is Josh. Title is research scientist. I work at Uber. My experience in graphs goes back to around 2007 when I got interested in semantic web. Co-founded Tinkerpop in 2009.
That's good. Good. You don't get too far into my first question. Amy?
Amy Hodler. I work for Neo4j. I handle the evangelism and program management for our graph data science area. And I think, is that it for the questions?
That's good. She also has a brilliant book on graph algorithms. Amy is with Neo4j and does brilliant data sciencey work. Juan.
Hi, I'm Juan Sequeda. I'm the principal scientist at Data.World. And I got into graphs around 2006-07 when I started my PhD, all about relational databases and semantic web and RDF graphs.
And then Denise.
Yes. Hi, my name is Denise Gosnell. I'm the Chief Data Officer at DataStax, and I come from the land of property graphs and Tinkerpop and using Gremlin to solve really cool data science problems.
All right, so those are our panel discussions. I have a stack of questions here we're going to be going through. We'll start the activities with a really simple question. Okay, personal computing platform, Mac, Windows, PC. Josh?
Mac.
Okay.
Mac.
Okay, so contrary to appearances, not a very heterogeneous group. Okay, preferred language for coding in. These are the softball questions, kind of warm up. Okay, Josh.
Haskell.
Haskell. Python.
I don't program anymore, but Java is what I do. So.
Python.
In our training workshop this morning, 40% of the attendees were Python, and only 25% were Java. So. Yes. Okay. What problem got you interested in working with highly connected data? What kind of sparked your fire for this topic area?
Okay. So there's a problem, and then there's also the accidental stumble into. So which one do you want?
The short version of all of that.
Okay, all right, short version. Short version is that I was doing a master's in mathematics, and I got locked out of all my classes, and so I had to take this class called graph theory, and I was dragging my feet because I legitimately am not the person who reads the textbook before class, and I thought that graph theory was about bar charts and basic business data analytics, and I didn't think it was going to be great. Turns out that graph theory is awesome, and I kind of had this epiphany about working with connected data in an area that I had never thought of before. So that's how I got started, and my favorite problem of interest is tracking people's identity through their relationships within different types of data sources, specifically kind of social media or telecommunication, highly connected data.
Nice, nice. Okay, I'm going to throw that question to the other end. Josh, what first got you into the connected graph data?
So I got into graphs by way of basically personal knowledge graphs. I was really fascinated with the concept of taking personal knowledge and representing it in a non-linguistic way, in a way that you could potentially query it and perform inference on it. And so tail end of 2006, I heard about this thing called the semantic web and RDF, and that really clicked for me. And then just started building cool, weird things that led to other cool, weird things.
Cool. Juan, what prompted your...
Yeah, so I got involved through the semantic web. So I attended a seminar about semantic web like 2005. And for me, it was like, oh, it's really cool, all these things about ontologies and search and stuff. And that got me, I got excited through the ontology part. And then I came here to do my undergrad. I was doing my undergrad and did my PhD. But during my undergrad there's my advisor said, there's a semantic web thing. What the heck does that mean? I know what databases are. And then kind of like, let's understand the relationship between these two things. And that's how I got into like, oh, there's these graphs and databases.
Nice. Okay. And Amy?
Well, that's kind of an interesting story. I actually got into it by reading. I started reading a couple books at the same time. One was called Black Swan, which was about risk analysis in economic markets and in actually all sorts of areas. And then also The Information, which was James Gleick about information theory. And that kind of led me down the road. I went from information theory to complexity theory, and then just started to take some classes online. And there's some great classes online on complexity. And how do you manage complexity? It's through a network. What is a mathematical representation of a network? It's a graph. So I just was hooked from day one. Yeah.
So it's all standard ways, and I suspect several of you kind of got into this domain with similar types of questions. Or maybe you just had a potential client that said, use a graph database to solve my problems. And you just got thrown at it, and you left that meeting. Well, am I the only one that left the meeting asking, what is a graph database? They were told. Okay. So we have been collectively, okay, I've been working with graph data for 5 years. Which of you have been working with it for longer? I think most of you. Okay, all for longer. I think the general consensus, if we were to query the room, would be that it's not exactly the most mature of technology areas. So my question for you now is, given the current graph landscape and ecosystem, where would you say is the biggest gap in terms of tooling or other needs for maturing in this system? What problems should be solved by now if we had right tools? So for example, a relational database market has the ORMs, and we may have something like that, but it's a very mature technology, and it allows us to kind of ignore aspects of using relational databases. So where should we have kind of tooling or more technology available in the graph? This is open for the group.
So I'll start and I'll get negative points. So we need a graph modeling tool. That's why we created Grapho. So
Shameless self-promotion?
No,
that's marketing Muppet.
all of it. So I started to start.
Okay.
Honestly,
This is a really good point. So you bring it up.
I mean, it's kind of ridiculous that we do not have a modeling tool for graph databases, right? Because there are so many modeling tools for relational databases, and UML, and we've been doing this for decades, right? So it's kind of dumb that we don't have this. So that needs to get solved, right? And I'm doing my piece to fill in that puzzle. I think that's one. And the other thing is standards, right? We don't have. So again, we do the RDF and the property graph. RDF has standards. The property graph, they need standards. We're working on that. I honestly think that we are probably in the 1980s. Of the equivalent of SQL standards of what we're doing to property graph. So it's going to be a long road.
We will be getting to standards more later. There are some questions about that. So good start. Anybody else
So I'd say I definitely agree on the standards, and it's great to see ISO and some other people try to develop standards to move forward, because I think that, I won't go too deep into that, but that does kind of set the foundation for graphs to take off and be adopted in general. The other area that I think needs attention, and there's gaps, is just integrating it into the larger workflow of what people are doing today. So ETL in, ETL out, visualization, how do you move your data in and out of graphs? Because I don't think any of our data should ever live 100% in one location. It's probably going to move around.
Good points. Good points. Any other thoughts from the others?
I kind of just want to agree with the previous two speakers. Yeah, not even standards, but formal data models is something we've been lacking for a long time in at least on the property graph side of things. It's
So what do you mean by a
amazing.
formal data model? Like,
Well, property graphs, I think, sort of caught on and became popular because they were easier for developers to wrap their heads around right away. Okay, so you don't need to go and read a spec. You can describe the property graph data model in a few sentences. You have nodes, you have edges, and then you can have properties on the nodes, you can have properties on the edges. Okay, here's a Java API that you can use to just go and build your application. Whereas with RDF, it's a bit more formal, but there's a lot of power that comes with that formality as well. And I think we need to combine the best of both worlds. To Amy's point on kind of industry adoption, if you look at the data infrastructure of many of the big tech companies, obviously I know Uber's the best. I know Uber's
shameless self-promotion.
Infrastructure. Okay.
Nicely done.
That was a slip of the tongue. But yeah, graph is a tiny fraction and could be more central.
Yeah, there's a lot of things, some that I agree and some that I actually strongly disagree with up here. But when you first asked the question, I believe that we do need to start with what we were saying here. We need that common framework for how to model a property graph, because we've gotten very lost right now in the art of what you can do with this piece of data and this edge. And it's kind of exploded a little bit. And so I think that what we're really missing to start with is that common set of application patterns that are the most common things that people are doing with property graphs. Because I do think that exists, and I do see them coming down, which I guess now is going to be creating more formal specs that graph folk might not want. But I do think that's needed so that when you're getting started, there's a lot less of the art of the possible and getting lost with all of the modeling and using more of like a formal template of how to get started. So
More kind of like a self-serve training program for developers that are trying to work with this technology. Here's some known patterns, and here are some ways to start expressing these things in technology.
Yes, specifically on the known patterns. Known patterns of how you model this problem, common ways that you would query the data, how you would access it, and the type of information that you need to then solve the larger business problem that you're going after. I see templates that our customers and that the people I've been working with around the world have started to converge on. And after like the first 3 or 4, you kind of open up into
this is the same problem over and over again.
Yeah. So
Yeah.
I agree we need models, and I also then want to push that we need a little bit more common templates on how to solve the really common problems.
I think the tough part there, and I agree with you, but I think the tough part in that is that every customer problem can be somewhat unique because the data is different and what they need to do is different.
Yep.
So I think the tough part for all of us is to figure out, how do you put together those common recipes in a way that are flexible enough so we don't lock people into one model or one way of doing stuff and then they can't innovate. So it's kind of maybe that's why there's so much of a gap. It's kind of a tough middle ground to walk there.
I think there is a disconnect with the semantic web academic community and kind of the practical graph community, because the semantic web academic community has worked on this a lot, right? And unfortunately, the bridges have not been made. So from the practical industry point of view, they're like, oh, here's this problem that we have, let's go solve it. And it's like, well, there's a group of smart people who have been doing it. But yeah, there's a gap, and we need to go fill that gap. And this is not, I don't want to put the blame on any group. I think if there's a blame, it's on both. The academics who can't talk to the industry, and the industry who's not talking to the academics.
Okay, so I want to dig into that bit a little bit, because 3 of you have PhDs, so you've clearly spent some time, significant amount of time in academia. but you're all in industry in some way, shape, or form right now. So you've kind of moved to the other side of the fence, and we're all degreed people to some sense or another. So what does let's start with I think where you are now looking back. What does industry need to look to academia for? Or what questions should industry be going to academia for? Since most of us here, I suspect that 70–80% of the audience is more on the industry side. So how would you guide them in terms of interacting with academia? This is the type of stuff that academia brings to the table and the type of things you want to ask of them. How would you make it successful from an industry perspective?
So I have a lot of thoughts on this. So I'm going to ask you a question. Who from here is from academia? Okay. Right?
Okay.
So 2 people, right?
Two.
Right? And you're kind of, right? So the only person here is Semi. He's a professor from Waterloo, which I actually invited him to come here. So I think the way I would phrase it is, I think it's more about what from academia should be going off to industry.
I know, but I didn't ask that question
No,
yet.
but I'm saying I'm rephrasing it. So here's the thing. Academics are the ones who are trying to solve hard problems. And why not tell them, go talk to this bunch of people who have problems and go figure out and see which are interesting scientific and not engineering challenges, scientific problems to go solve. And I think from the industry perspective, people need to go solve problems today, like whatever's right in front of them, right? So you can't go spend resources and say, let me go talk to people to think about problems I have 5 and 10 years. So, but I do think that we need to have like more of your innovation labs type of folks saying, okay, let's go have tighter connections with industry and with academia, with those academic folks who are interested in trying to talk to industry. I believe that the strong impacts that we will have in science and industry, in connection with industry, are the people who are willing to talk to each other. So, I mean, that's my message: is go cross the bridges.
But which problems, though?
I don't know, but the thing is, I tell, for example, I told Semi today, he came in, I said, I am glad you came here because you are an academic and you're hearing everybody from industry talk about their problems. You're hopefully going to leave with some idea of how the real world is talking about it. And maybe you'll say, that's engineering, that's boring, fine. Oh, I think there's something interesting. Let me go talk with you, and I want to really drill down on the problem. That is what I think we need to, I think that's what academia should do, so we can keep doing something that's practical but still interesting scientific, something that is unknown.
So I'm wondering, Josh, you're in a research role within a extremely well-funded company. Do you see anything from that model there, or what have you seen from that experience that you would see as kind of a best practice or something that should be replicated elsewhere? Have you learned anything from that?
Well, they let me call myself research scientist because I get to spend a certain amount of my time on kind of experimental things and writing papers and so on. But one thing I see too much of in industry is reinventing in wheels. Engineers tend to create fast, efficient solutions, but that solve a very limited problem and with a kind of a very limited perspective on what comes next, how to integrate their systems, and so on. So I think industry can take a lot from academia by simply being aware of what's out there. And I'm going to keep coming back to formalisms and abstractions. You see the most common technologies sometimes are just dumb, simple things like protocol buffers used everywhere at companies like Google and Uber. And so many engineering hours are lost just arguing about the idiosyncrasies and protocol buffers and how do you map between protocol buffers and thrift. How do you do this, that, and the other with this particular tool that was not really built with all these other concerns in mind. So I think to the extent that we can move to things that have a little bit more, a little bit more mathematical rigor behind them, I think it'll go a long way. In the case of data models, just kind of formalizing that data model in such a way that you can easily integrate your thrift data with your protobuf data, with your Avro data. And there's few barriers to putting things together.
Yeah, I think personally I would love to see more of the engineers kind of putting their heads up. And I've seen in some environments where they do this really well, where they're like, hey, well, let's do a survey of papers and take a look at kind of what is the understood best approach to this, as opposed to just kind of slapping a solution together and shipping as quickly as possible. Some of that, I think, is also going to come into, you just need some understanding from the business that we're building complex things. And that if we're going to build them well and do them right, we need to kind of take the foot off the gas a little bit and maybe be a little more strategic in some of our decision making and some of our design process on that. So any other thoughts from Denise or Amy in terms of kind of this communication between academia and industry?
I guess just an observation in listening to everybody else is that we didn't come up with what's the thing that should be brought over, which I think was the original question, but I actually like better the answers, which was developing a process where you're actively engaging with the research community, and the research community is actively engaging with commercial, which I think they want to know what people really are. I mean, I talk to academics, and they're always asked, can you come talk to our students about what your customers are doing with graphs? Because they don't know. They're like, what should we base our next experiment on? And we aren't seeing the forward-looking research. So I guess what I'm hearing, and it reiterates something that I would like to do more of at my company, which is to do back and forth with academic conferences, communities, doing more hosting of academics. So we answered a different question, but I liked the answer.
Yeah.
So I thought it was pretty good.
I mean, just the database industry itself is a result of academia working with industry completely, right? So there's no reason why you can't see this also in the graph database.
Well, I think it's also interesting to see that the thing from a technology implementation point of view that validates a technology solution is an academic paper oftentimes. And it's not just, okay, I've got a working methodology, but I've been able to explain it well and provide a rationale for my engineering approach. So we had the Google Spanner paper. We've seen this with a number of other things, other technologies that have started out as skunkwork experiments at various companies that turn into a productionized piece of software that eventually gets kind of consumed by academia and pushed out in other things as we're seeing that. So I think that you're right.
Yeah,
Denise, any final words
I
here?
disagree with your statement to take your foot off the gas.
Okay.
I disagree with that because I do truly believe that moving fast is much safer, because I don't mind failing.
Okay.
So if you move fast and you try and ship code as quickly as you can, the purpose of that is to get your solution out the door and see how it's going to work. And the worst that can happen is that it blows up in your face. So what? Go fix it.
Okay. I'm going to give Denise an extra 15 points for arguing with the moderator. Nicely done.
Oh,
and
okay.
And the point is also very well made and point taken.
Cool.
So, okay. Going back to kind of your personal experience, at some point you got your graph. So we talked a bit about kind of where you started in graph in this. At some point you kind of had, you had figured out the graph technology at some point, and you got to the point where you knew how to use these tools and solve problems. Did you ever have a point where you say, oh, wait a minute, that's a graph problem, and I know how to solve that?
I have the inverse of that all the time, which is that is not a graph problem. What are you doing?
Yeah.
How does that go?
Those are. I can't be the only one up here,
No,
guys.
so I don't think it's about like I can solve it. I think it's like it's an aspirin or a vitamin. It's like, oh, like how many talks I heard today about fraud detection? It's like, yes, you can do fraud detection with graphs. We've been doing fraud detection without graphs forever, right?
Yeah.
So it's not that magically one day we can solve this fraud detection problem because of graphs. We can solve it better, faster, right? So it's at the end that way. It's just more of a vitamin, right? I'm making something that works better.
Yeah.
Now you could argue I'm making it much more better. I'm saving a lot of my money, right? But what are like the true problems that are aspirin? Like I could not solve this problem, but because of graphs today, I can solve it. Honestly, I don't know. I find more what you're saying. I agree with you with this, and I think it's just we got to be completely honest about this stuff. And the problem and the issue is that we go talk about and go sell the technology, and we got to go talk about what are the pain points, the business problems that. Oh, by the way, the people who are signing the checks don't care about the technology underneath the hood. That's my perspective.
Yeah, and I kind of back to that first question though about the common patterns of what people are really starting to solidly use graphs for. I would squarely want to talk about pathfinding. Yes, you can shove a square peg in a round hole, and you can do pathfinding in an RDBMS if you would like. But the expressivity and how much easier it is to do in graphs, but that's more back to your point of graphs are enabling you to solve harder problems with a much shorter map
That-
between the mental model down to the actual physical data layer on disk. It's much closer because of the way that you're expressing the data.
Yeah, and for me, graphs is because the way you, everybody said this, right? We need it, the way you model things on the whiteboard, the bubbles and lines, that's how your data is, and that's how you represent and access your data. That really saves you a bunch of time to go do that. So it is really just like the natural way you think about it, and that kind of saves you time. That's great. But could we have done it a different way? Yes.
Yeah.
At the end, you just
Well,
need to.
I'm curious. I would like to hear, Josh, you don't have anything to say on this. You just work for one company. Amy, you actually deal with several different companies. So where are you seeing kind of the value realization among the companies?
When you talk about it from a monetary standpoint and where our customers are
Is there
receiving.
any other type of value realization?
So from a monetary standpoint, where I would say I've seen the biggest gains from customers is actually in the fraud space. I know you say fraud, but it is looking at patterns and trying to break through the way people have been doing things. And I would say one of the lowest hanging fruits for a lot of our customers in fraud, but in general is to take what they're already doing, especially if you're thinking about kind of machine learning and feature engineering, and just adding relationships to it. You don't have to change your pipeline. You don't have to change your teams. You're just adding in things that are really predictive, because relationships are highly predictive of behavior. And so it's the return on effort is just really high when you can add graph features to it, and fraud is just so much money to be recovered with even a small half a percentage increase.
So it's a vitamin aspirin at the same time.
It's a vitamin, aspirin, and probably an accelerant of some sort. I don't know.
And I guess,
Fair point.
and from my perspective, what I think is really important is, yes, we work with tons of people who solve fraud with graphs, feature engineering, great uses to bring new relationships in. But to me, it's about, that's great at this level, but what are you actually doing under the hood that is that new feature in your model that is going to create whatever that you're looking for? Or what are you really doing to find an outlier in your distribution that relationships are helping you? And that's where I think that the templatable approaches of using specifically a path, its feature of its length, or
Okay.
things like that. So like digging down one layer below this idea of fraud, or one layer below this idea of I need a feature, and understanding, well, what is it about your graph that you're actually calculating for it?
So
That's where
maybe-
I'm pushing for those more common templatable patterns to come from.
And introducing maybe a little more rigor
Yeah.
in terms of your understanding of how that problem solving is really working.
Yes.
And
Yeah.
I just want to jump in and say that just sparked off something that really concerns me when we talk to customers that think they can just throw data at fill in the blank, whether you're talking about.
Oh, we don't see that ever.
Yeah, well, it's a new algorithm, it's a new feature, it's a new, I'm just going to graph it and magically things, and they disregard subject matter expert and domain expertise.
Yeah.
Oh, yeah.
And that really bothers me. It's like you're leaving the science out of the data science. You have no rigor, and you get a score. And I've talked to people who said, "I got a PageRank score. I'm running with it." I'm like, "Wait,
does that mean?
what did
you mean?
What did you, do you even understand how that works? No idea how it actually works." And so that does bother me a little bit in what we're doing with customers, and maybe doing more recipes, more patterns, more templates would help alleviate that a little bit, because we can't leave out our SMEs.
I
So I'm
couldn't
not the
agree
only
with
one
that
that's-
anymore. Yeah, I mean, because you've got these templatable things that you do with RDBMS, but the statistics that you would, whatever you would be feeding off that only makes sense to the SME.
Yeah.
And they only understand from their distribution and knowledge of their understanding of the data how to apply it. And I couldn't agree with you more, Amy.
Yep. So Denise, who is your favorite graph database book author who is based in Alaska? Dave.
Dave Beckberger.
Don't know how that got in there. Okay, so Gartner has their hype cycle. For a review for anybody, if you're not
That's
up to
good.
reading on your maybe your Gartner subscription has lapsed in the last. So if you don't know, they're like tens of thousands of dollars. It's kind of ridiculous. But they have their hype cycle, and it has the innovation trigger, the peak of expectations, the trough of disillusionment, and then a slope of enlightenment. So you kind of go up the hype cycle, and then it comes down, and then that's. According to Gartner in 2019, last year, which was just weeks ago, graph analytics is still technically in the peak of inflated expectations, but it is almost in the trough of disillusionment. Agree? Disagree? Perspectives?
All right,
I mean, it
I'm
is
gonna
Gartner.
I'm gonna answer a different question. The other thing is, if you've read the study, I believe they say that they expect, Gartner also estimates, and they love to make estimates, right? That there's they expect 100% growth in the market by 2022.
Yep.
Yeah. So, yeah. So there you go.
Is that for graph analytics specifically, or
Graphs in general.
graphs in general?
Yeah, graphs in
I
general.
agree with that.
Yeah.
So, okay, well, that gets into another question. For a few years now, we've been talking about the year of graph.
This is the year.
Every year is the year.
So we keep talking about the year of graph.
Weren't we all on the stage in 2016 saying it was the year of the graph?
So my question is, who do we know that was in the 80s? I'm sure people here were in the 80s. And did people have the conversation, is this the year of the relational database? So is this really the question? I mean, this is the marketing like Muppet that I'm giving you.
Yeah.
Because I think we should just stop asking this.
Okay, you write the question.
Can we high five?
Okay, so technology labels like AI are for things we don't understand, but solutions that have demonstrated value and understandable have a different label, but they're really just kind of the same thing. Like facial recognition is AI that I understand.
And I really like that last phrase that you just used, though, so thank you for that comment. Solutions that become valuable and are understandable. If you use that as the topic and kind of a measuring stick, and you're going to totally debate me on this one, so I'm looking forward to this. If you use that as the measuring stick, I kind of, when you take a look back through the database innovation cycle, I see about a 10-year lag between initial innovation and when you reach that point at which people understand that it's very useful and it becomes widely adopted. For me,
I agree.
Well, hold on. You'll see where this is going. For me, I see that back in you see that original innovation with RDBMS in the 70s, wide adoption in the early 80s. Follow that now with NoSQL, and then wide adoption. But if you follow that through, it's about a 10-year lag for each of those windows. And where I think you're going to really disagree is that for me, I'm coming from the property graph space, and I see about 2009, 2010, Marco can correct me, but I see that's really when the original innovation started with using property graphs and query languages that were going to be able to enable you to use them in that
Come
light.
to my talk tomorrow at 10 o'clock in the morning. History of
Shameless
knowledge graphs.
self-promotion.
There's
I'm
my
actually
answer.
going to give
Yeah.
you time to put your talks at the end.
Well,
But-
anyways, my point being that for what I'm looking at and what I'm following, I saw 2009, 2010 as when property graphs really started becoming a new invention that was being created, and that about 10 years later, we're about here now, is when we're going to really see that their value is being adopted, or we'll see what happens. But to me, that's what I'm looking at, following RDBMS, NoSQL, et cetera.
And apparently Gartner agrees with you. So, Juan, you have a
No,
counterpoint that Denise has been baiting you on?
So the point is that graphs are really freaking old, right? So
exactly.
Okay, so if we're gonna go talk about graphs, and again, I'm giving this history of knowledge graph talk tomorrow. We're going this. I mean, what was the first database ever invented? Charlie Bachman did IDS, and this was a network database. It was a graph database back in the 50s,
Yeah.
right? That's all we did. So we're just what is fascinating. This is actually a question I have. Is why have we over the last half a century have come up with so many different data models? There is this really good survey on graph data models. I think it's an ACM survey paper, and I think there's a list like 40 different graph data models, right? 40 different graph data models over the last 40 years, and then we have so many tabular and then trees and stuff. Why do we go through this? I don't know. It's really interesting. But at the high level, we talk graphs is just coming and going, and now it's back. So we got to look at history.
I also think, though, there's a big shift recently in just the adoption, the widespread adoption.
Yeah.
And companies, like yours, UBS, Marriott, Visa, you name any large company, and they're looking at graph, they're using graphs in production, and I think that's been a big shift. This is no longer just an isolated research project, that you're actually seeing these be added to production use cases. And I think as opposed to seeing it as a replacement for RDBMS, you're seeing it as an augment to what they're already doing. And I think that's the big shift, and why it might not appear like, oh, this year everyone's going to just shift over and be on graphs. Well, no, it's just that it's going to slowly infiltrate what's already there. So I don't know. I'm actually curious, at Uber, is that shifting from one project to 5 projects to, what's the shift look like for you guys?
So we have actually several knowledge graphs. One of them is for risk and safety. Fraud is a big part of it. But there's a bigger task, I think, to, like I say, make graphs relevant to more of the company's data infrastructure. And that's happening slowly and in stages. So we have good identifiers. That's part of it. That they are not particularly well typed. So we had to develop a controlled vocabulary of entities and relationships. Controlled vocabularies are also used for, basic things like what is a URL? What is a timestamp? Is it a timestamp in seconds or milliseconds? Some low-hanging fruit to just define certain bits of vocabulary once and then get them reused. I see that as kind of a foundational step to building a graph, and that's kind of where we were as of last year, and now we're getting to the point where we're more in kind of an entity and relationship type model, and that's kind of more company-wide as opposed to just these individual, sandbox things that are full-on graph.
So you want to agree to the terms first, and then based upon the agreement of terms, you can start actually doing interesting work, as opposed to just squabbling about terms. Speaking of squabbling about terms, I'm curious. Nice segue, right? How we've all just raw industry for beginning to take on a graph and adoption, and Gartner for projecting a doubling of that. Where do standards fit in this process? So what is the gap between what we have for standards right now and where we should be? And how is that going to facilitate the solving of real problems?
Yeah, and I think we kind of talked about that a little bit in the beginning, and I think we all agree that standards are good, and everybody has one. But sorry, that was just right there. But I do think that what the ISO body has done to say that we should develop a label property graph query language that's standard. I think that's a huge validation of the pickup in the market and an understanding in the community that the more we can develop standards in languages, that the more people can invest in their own careers, and companies can more easily invest in things and applications that can move and be ported to different areas. So I think we're still getting there on the label property graph. I think much farther ahead on the RDF world, but I think we kind of talked about that. I think that is essential to see graphs actually take off. And if that does not work out, then I definitely think we're going to be having this conversation. When you think like 2022, I don't know, 2023, we're going to be. This is the year. And then the recipes and the other standards that you mentioned earlier, Denise.
I can't be the only one thinking of the XKCD comic. Right? Right, this is the comic where you've got 14 standards. Like, I'm going to define a standard to rule them all. Now we have 15 standards.
Yeah.
I think I have been watching y'all's work with creating standards, and I think this is something where I'm very much an active member of this community, but I've been pretty silent on it. Notably, just because from my perspective, I'm looking at what people use to solve problems and to solve complex problems, and what is the most popular way that people are solving them. And I like to let the community determine what that is instead of coming the other way.
So we agree on this.
Okay.
So I agree that the whole 14 standards, 15 standards. So I think you're going to have ISO doing something, and there's going to be that body governing who's going to police everything, and they're going to have all the politics there involved. All right. But so something that we did here was. Throughout the LDBC, the Link Data Benchmark Council, we've created kind of this community group to be able to kind of funnel things, just like recommendations or like.
Yeah.
So the way I like to state it is, imagine you put a bunch of really smart people in the room from industry and academia, and say, let's go discuss about these topics, and that's what we're doing, at least for the schema aspect right now. So we have this group. I mean, you're on that list, right? So we're let's go discuss this from a community perspective, and let's just let everybody know what the community thinks about it. It's public. You pass this on to the ISO folks, and then there you go. You see what the community is, and this is really important because before it was all completely kind of isolated, and I think that's what would generate a bunch of different problems.
I must personally commend Juan for absolutely fabulous leadership with the Property Graph Schema Working Group.
Yeah, that is true.
So you have done an exceptional job. I don't know that that's been publicly acknowledged, but it should be. You've guided along, you've herded a lot of cats on multiple continents, and you've got the process moving in a direction and getting momentum, which is just amazing. So just hats off to you. Well done, Juan. So that being said,
how many points did I get for that? Come on.
Okay, 75. Definitely going to give you 75. Not a full century mark yet. Well, we haven't had that kind of stellar response yet, but definitely, for the body of work and a Lifetime Achievement Award. We'll get you one of those too. So okay, but you brought up the point of schema. We all deal with schema and stuff. What's your attitude towards schema?
I'm coming from the perspective of what people are using graphs for. And I just want to, let's just stick in pathfinding. You cannot solve pathfinding problems with GraphQL, especially if you follow their spec. And if you try and even extend it in the common ways that other companies are forking the spec and then making their own, you have to make a lot of really tough choices. Here's one very specific choice. When you're pathfinding between people or entities, vertices, and edges, if you want to use GraphQL, you only can filter on one of those types, only the vertices or the edges. You don't get both. There's no way to make the language work to solve that problem. It's fundamentally the most popular way that people are using graphs, and GraphQL as a design is not going to help you fit to that problem. And so I think we've got a little bit of an issue right now with the name of GraphQL then being thrown over that this is the language to solve graph-shaped problems.
It's supposed to solve all my problems, not just graph problems.
Yeah.
It's the only environment they're supporting directly with tooling and everything.
And I think that's a big mistake is what I'm saying.
I just want to make sure that this gets caught on the mic and everything. He's saying that the vendor has told him that this solution will solve all of his problems, GraphQL problems. Normally at this point, I would call a marketing Muppet violation there. But he's not doing this as a representative of the vendor. He's saying from the perspective of a developer, this is what I'm being told. And here we have panel members saying, yeah, and you're going to get painted into a corner, and good luck with that.
You will get painted into a corner, and you won't be able to solve the very most common graph style of problems with that language.
Still, there are ways of hiding a proper graph schema language in GraphQL, for example. The same is true of protobuf that I mentioned. You can use protobuf as the source of truth for a proper graph schema. You can use gRPC for graph queries, for well-typed graph queries. The same is true of GraphQL, yeah. I mean, look at Olaf Hartig's work. That's what's one approach to expressing property graph schemas in GraphQL, SDL, and there are others that are thinkable.
And I think you said something earlier, like you could do something using GraphQL, and actually we use GraphQL a lot. It's very powerful, but we wouldn't use it for certain things. To your point, so I think that certain tools are good for certain work, and if you're doing seriously graphy work. And graph queries, I do what Denise said about letting the community lead the way. That's one of the things that Neo's tried to do is understand what practitioners want and try to do something that they want and that we think that they'll want in a few years, which does mean that there is some guidance there. But we're trying to anticipate what do the people in front of the keyboard want and try to make it easy for them. And not saying that that's the only thing you would ever use in your daily life, because, like you said, you may use something else.
Well, Amy, I want to follow on that question along the lines of kind of like this is what the community is asking for. And one of my questions was, particularly for those of you who are involved with industry and with multiple customers, kind of where are the customers pulling you in this direction? Because we tend to come at this from I've got a set of tools and I've got a set of ways that I can solve problems, and the customers are saying, well, this is my problem, this is where the value is. So where's the market pulling us this technology area?
So I can answer from the area that I focus on, and I'm not as much of a database person as I am an analytics person, so I'm sure I'm not going to answer those completely right for the other side of that, the more transactional side. We are getting pulled into the machine learning workflow by our customers, very hard, and it's almost to the point where, we have to keep up with just resources and catching all the opportunities. So they are pulling us hard there. I think part of that is because in that whole machine learning space is they're looking to innovate and do things that are different. And because they're trying to do something different, they're willing to look at a different technology and doing things and investing in the resources to learn something different. So we're getting pulled there. first and foremost, the feature engineering, but the next space right after that they're starting to push on is graph embeddings. And so you can learn on a complete path. So when you understand what the path is and the traversal, I now want to learn on the whole patient journey or the whole customer journey, not just on a couple nodes. So that's kind of where, at least in the area that I focus on, we're getting pushed the fastest.
And to actually commend this gentleman's point, if you don't mind, we're getting pulled really hard into making graph query languages easier to use. So they are coming back and saying, we want GraphQL. And we're at an impasse right now because of the common ways that people are using graphs in production for transactional data stores don't fit well into the spec of that language. So we're at an impasse, but we're getting pulled very, very quickly into make this query language easier. We love Gremlin, we love Tinkerpop, but we need to make it easier.
So Data.World is not a graph database vendor, right? We're a data catalog, and we're a cloud-based data catalog powered by Knowledge Graph and graph technology underneath.
Denise just holding it.
I'm sorry.
We're the best damn data catalog. Right?
There you go. Go ahead and own it.
Yes.
Okay, so from your broad perspective of providing all these amazing solutions to the client across this spectrum of data opportunities, where do you see the market pulling you guys?
So for us, the way I like to see it is so again, we're not a graph database. So from a data catalog perspective, what we see.
But you're dealing with customers.
Yeah,
So
no,
what
no.
do customers ask you for?
So I see these three phases, what I call like crawl, walk, and run. So from the crawling perspective, people in their organizations, they don't even know what data they have, right? They will have hundreds, if not thousands, of different data sources, and every database is gigantic, and they want to be able to just go catalog that information. So what we do underneath the hood is that when we go catalog, we start creating that graph and connecting all these things together and putting the business glossary and that stuff. And then people want to go say, okay, let me go start walking, and I want to be able to access my data within one platform. And then, well, that's again, you know that I have this data connected with this because it's part of the graph. Let me go access it. And then what we're seeing people now starting to do is in this running phase is, oh, my enterprise data is complete crap. I don't understand this. Thousands of tables and this stuff. I want to be able to put this semantic layer on it. And that's that graph layer that generates that beautiful, meaningful layer of data, which happens to be in a graph. And I map it to that really messiness of the data. And that's kind of the running phase. So what we are seeing people going in this crawl, walk, and run phase. So for us, it's about kind of being able to do data integration powered by graphs where the graph provides that meaningful view of data that the end user, the business user, actually understands.
So you're seeing graph as kind of an enabling technology to get into that fuller value realization from their existing data.
Because you're providing to the end user, to the business user, data that they understand. So I think. Oh,
that's an interesting way to clarify that. Good point.
So I think when we talk about like integrating data, I think using graph databases is about integrating data, is that we think about data is not just to put physically data together. It's because I need to go provide it to some human beings that are going to go do decisions on it. And we've really kind of defined our success criteria on the technology part and on the social part. Is like, I want to be able to understand how my data is being integrated because my end user is actually solving their business problem. And that's how we need to be able to do that.
Success based upon users doing happy dances in the hallways.
Because they solved the business problem, made money.
Yeah.
Yes.
Well, Josh, not that you guys are all doing happy dances in Uber's hallways, which maybe you are, but that kind of sounds like what you were describing on what you have rolled out and deployed at Uber when he was talking about the crawl, walk, run approach.
Yeah, we also have a data catalog, and it is better than a lot of our data in terms of how it's curated. We recently standardized the vocabulary for it. So yeah, I don't know if I have anything particularly interesting to add there, but yeah, we went through. I'd say at Uber things have started very bottom up. Users just writing hacks, and the hacks kind of turning into more mature systems, but not particularly well integrated. That goes for our data sets. We have like 200,000 data sets, and a lot of kind of, like I say, very messy schema. So that's something that we're working on getting to the more to the walk stage, if not the run stage. I think the run stage is going to be where we have a good amount of deployment of really strong schemas throughout the company. And that's, I mean, that doesn't sound like much, but from what I understand of other big tech companies, it's the same thing everywhere. It's kind of, in terms of schema, a big mess and one-off solutions.
Does anybody have a really pristine, well-curated data set that's achieving amazing amounts of business value? Okay, so
Exactly.
Marco was playing peanut gallery back here, and Marco wants to know if your success is a virtue of having a really simple domain.
I can
Or
answer
is it
both
email?
questions, but what I think you're asking is, doesn't Uber have a pretty well-defined domain model? We have our vehicles, we have our users, we have the devices that you use, you have trips and so on. Yes, so in every developer's mind, there is this domain model, which is fairly clear. The thing is, you have developers working across all kinds of different, all of our different organizations, all of our teams. They don't know what everyone's doing. They end up reinventing these concepts over and over again, and then they don't interoperate. So yes, there is this good, clear mental model that has not yet been translated into a consistent ontology. So it's a relatively straightforward thing to do, to develop that ontology. It takes more time to get it adopted and reach out into every place where our data is used, into storage, into streaming, into RPC.
So I want to thank you all for coming and joining us tonight. And please feel free to come back tomorrow, ask us questions, come to our talks. I am not talking tomorrow. I'm done for the weekend and looking forward to enjoying each of their talks. And I'll see you tomorrow at Day Texas. Thank you all. That's a wrap.
Thank you.
Hey, and let's thank our moderator. Good job, moderator. Million points.